guys, today we're going to do 6-2 multiplying and dividing radical expressions. The objective is to multiply and divide radical expressions, and the essential understanding. You can simplify a radical expression when the exponent of one factor of the radicand is a multiple of the radical's index. So the first property is combining radical expressions by multiplying or finding products. So if the nth root of A and the nth root of B are real numbers, then the nth root of A times the nth root of B is equal to the nth root of A times B. Basically, we need the same index, and then we can multiply our radicands. Multiplying radical expressions. So, problem 1. The cube root of 6 times the square root of 2. The first things we need to check is, do we have the same index? We do not, so this cannot be multiplied. Because we do not have the same index. B, the cube root of -4 times the cube root of 2. We are doing both cube roots, so then we have the cube root of -4 times 2. -4 times 2 is equal to the cube root of -8, and the cube root of -8 is -2. If the radicand of nth root of A has a perfect nth power among its factors, you can reduce the radical. If you reduce a radical as much as possible, the radical is in simplest form. This is how we need all of our answers. We're not going to do this example, but we will do another example. Problem 2, simplifying a radical expression. What is the simplest form of the cube root of 54x to the 5th? There still may be things left in the radical, which is okay, but we want everything that we can come out. So what goes into 56? We know that 6 and 9 go into 56, and I'm going to keep simplifying. So this is 2 times 3, this is 3 times 3, and this is x, 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 and x. Since my index is 3, excuse me, I know I am looking for groups of 3. I have one group of 3 and another group of 3. So if I rewrote this, it's the same thing as 2 times 3 to the 3rd power times x to the 3rd power times x squared. And I want to take the cube root of this. I know the cube root and the powers cancel each other out. This part is all optional. We all know that once we find our groups, we can cross them out and take one out, but I'm just showing why we can take them out. So the cube root of 3 is going to be 3. The cube root of x cubed will be x. And since we can't take the cube root of 2 and the cube root of x squared, that stays in our radical. So the cube root of 2x squared. This would be our simplest radical expression. So simplifying a product. Now we need to be able to multiply and then simplify our product. So we have the square root. Our index is the same. 72 times 10 is 720. X cubed times x is x to the 4th. Y squared times y to the 5th is y to the 5th. So what goes into 720? I am going to say 8 and 90. What goes into 90? 9 and 10. 2 and 5. 3 and 3. 2 and 4. 2 and 2. So now I just need to look at the end. So 2 times 2 times 2 times 3 times 3 times 2 times 5. Because those are the simplest form. Now look for groups of 2. One group of 2, one group of 2, and another group of 2. So for each group, I'm taking out one of whatever's in the group. So I take out 1, 2, 1, 2, 1, 3. And now I need to do the x's. I can't do anything with the 5 because I know there is no square root of 5. If I have 4 x's, that means I can make 2 groups of x's. So I have x times x on the outside, and 5 y's. I can take out 2 y's, and 1 y will still be left in the radical. So in the radical, I have 5 times y. And then we just simplify our coefficients. So 2 times 2 is 4, times 3 is 12, x squared, y squared, square root of 5y. Now our second property would be for dividing. So if we have the square root of the numerator and the denominator, we can make the fraction together or we can separate it. We knew that. We just need to continue with the same index. So here, I'm going to divide. I'm going to combine 18x to the 5th over 2x to the 3rd. And I'm going to simplify the fraction before I take the square root. So this would be equal to, the square root would be equal to 18 over 2 is 9. 5x, x to the 5th divided by x to the 3rd is x squared. Now I can take the square root of 9x squared, which would be 3x. Going to do the same over here. The cube root of 162y to the 5th over 3y squared. So the cube root of 162 over 3 is 54. Y to the 5th over y squared is y to the 3rd. What goes into 54? 9 and 6. 3 and 2. 3 and 3. I have a group of 3's. Therefore, I can take that out. I have a group of 3y, so I can take that out. On my outside, I have 3y, cube root of what's left on the inside, 2. Another way to simplify a radical expression is to rationalize our denominator. So we can never have an answer with a radical in our denominator. So we have to multiply by something that will get rid of the radical. And the only thing that's going to get rid of the radical is if we are making it the same power as the index. So here, I'm going to split this up since if I divided, nothing would be simplified. So I have the cube root of 5x squared over the cube root of 12y squared z. And I'm going to break up 12yz into numbers that make more sense to me in the fact of taking the perfect cube root. So 12 is the same thing as 4 times 3, which is 2 times 2. So this whole thing is equal to the cube root of 5x squared over the cube root of 2 squared times 3 times y squared times z. Now I need to multiply by a cube root that makes each of those powers to the 3rd. So since I have 2 to the 2nd, I need to multiply by 2 to the 1st to get 2 to the 3rd. 3 to the first, I need to multiply by 3 to the second. Y to the second, I need to multiply by y to the first. And z to the first, I need to multiply by z squared. So now when I multiply those two radicals, I will get a denominator of the cube root of 2 to the third, 3 to the third, y to the third, z to the third. And since I'm multiplying in the denominator, I need to multiply by the same exact thing in the numerator. So my numerator is going to be 3 squared is 9. 9 times 2. So this whole thing is equal to 18. So 18 times 5 is 90. There was no x, so x squared. There was no y, and z times z squared. And now we need to simplify our denominator. So this is equal to, our numerator can stay the same. The powers all cancel and the root cancels, so I get 2 times 3, which is 6, y, z. Can we simplify anything in our numerator? We have 90, which is 3 times 3 times 2 times 5. We have nothing to simplify in our numerator, so this is our rationalized answer. You guys tried this one.